More people are moving to urban areas worldwide. The United Nations projects that large global cities will account for 68% of the world's population by 2050, creating a strain on infrastructure and services. To keep these cities operating smoothly, city governments need to leverage new technology based on intelligent IoT solutions that will power automated services, improve waste management, deploy self-driving car fleets, regulate energy usage, and digitally connect its citizens. And to successfully deploy a smart city like this, engineers will need to utilize the power of the digital twin. But what are digital twins, and how do you create the smart cities of tomorrow? Find out more now in Mechanical Engineering Magazine's special report. Digitalization is penetrating engineering practices, and digital twins are being developed to aid manufacturers in the development of products, machines, and even single examples of infrastructure. Now they are poised to take a bigger step on the development of smart cities, gathering design and digital information of individual pieces and spinning them into a whole. New tools and platforms allow designers to place their projects into a virtual neighborhood or city and test how they will impact nearby buildings or areas. At the same time, structural, mechanical, and electrical details of single buildings or infrastructure can be isolated or analyzed for performance and placement. It is happening now. ABI Research reported that by 2025, some 500 cities around the world will be using some sort of urban twin, up from just a handful now. They are being used to replicate buildings and their systems and operations, infrastructures such as highways, surface transportation patterns, and pretty much everything that comprises an urban neighborhood, town, or city.
Digital twin is a virtual replica of physical buildings and infrastructure assets connected to the data in and around them. And they are used for, and specifically in the built environment, for the purposes of optimizing design and planning, construction, and an ongoing operation of assets over their life cycle. What they do that's unique and different is that true digital twins aggregate massive amounts of information. So everything within the project lifecycle ecosystem. By becoming like a massive master data library, if you will, for a project, it enables users to run analysis in a way that they never have before.
Data is the fuel that drives their development. The more there is, the better the model. Digital twins have developed faster in the manufacturing and aerospace industries, but creating them for urban use takes this to the next step.
The mechanical space really, I would say, pioneered the concept of a digital twin. I would say the AEC industry is in a very different space, a little bit behind. You know, if you ask 10 people in the AEC space what a digital twin is, you're going to get 10 different answers.
That is crystallizing now as owners and government officials build on digital advances. Singapore was one of the first cities to create a 3D interactive model of the entire city and island based on topographical and real-time dynamic data. Detailed information, including texture, material representation of geometrical objects, and terrain, are incorporated through 3D modeling. Building models include its geometry together with walls, floors, ceilings, mechanical systems, and the type of composition of its building material. Data was gathered using laser scanners deployed by drones from above and surface vehicles below. But the model also includes static, dynamic, and real-time city data such as demographics, pedestrian, and vehicular movement and climate. The model allows planners to virtually test new systems, such as 5G deployment over a defined area, and identify improvements before installation. It can be used to simulate pedestrian movements in case of emergencies based on building and infrastructure data. And it's an ideal platform to develop simulation and modeling of the effects of weather or noise in a neighborhood or the greater city. Producing a dynamic digital build-out starts with capturing reality in the field.
There was, some boutique type companies out there that had some really advanced stuff for the time, and it was very expensive. We have thus seen a democratization of that technology, largely driven through cell phones, and the capabilities of being able to take pictures and capture imagery and sensor data, in a way that before was reserved to specialists. So the second thing that's happening too is just the maturity of cloud infrastructure and the very low cost of entry for people to leverage that infrastructure, and then the ability to scale without necessarily the upfront costs.
Deep learning and artificial intelligence help tie computer vision to a natural language processing capability that takes the real world as we interpret it and adds a layer of knowledge and understanding that Sutton said is very human in nature.
You are creating a system that can grow, more organically as the world progresses in a way that we, can't currently predict.
In Stockholm, city officials are moving on a project to digitalize the Swedish capital, using a mobile AI technology developed by locally based Universes AB. The first step that began last year is capturing real-time data from throughout the city using the firm's perception software. Rather than using laser scanners or LiDAR to gather surface data, the firm's software uses computer vision and artificial intelligence to record and input data from a smartphone. The consortium delivering Stockholm Virtual City includes the city and its taxi service, Taxi Stockholm. Its fleet is fitted with smartphones. They gather input and map the data to a dashboard in real time as the taxis move throughout the city. Personal data such as license plates or people's faces are automatically blurred or blanked out to ensure anonymity. The platform evolved from its original purpose to allow autonomous cars to make sense of their surroundings. The system does not produce physical geometric reconstruction, but is a tool to understand the environment's semantic nature, to provide a platform for the city to study real-time traffic flow, pedestrian and crowd distribution, and congestion points. The dashboard is continually updated, allowing the city to track and analyze traffic and pedestrian movements. Some ambitious smart cities projects that would have highlighted new digital platforms have lagged or even stopped. In India, the state of Andhra Pradesh announced in 2018 it would build a new capital in Amaravati based on City Zenith's platform. A change in government and loss of funding stopped the project that would have used the digital twin platform to plan, design, and build the new greenfield city. Still, Jansen said early work showed results.
We were to create a twin of a specific district that would aggregate all the different models and input from different architects working in different parts of the world and allow them to run scenarios that would predict the impact of those schemes on resultant ambient heat temperatures at street levels. So basically microclimate simulations. The goal was to see what types of architectural configurations could be investigated and conceived and tested to reduce average street temperature by as much as 8 degrees in a peak of summer, which is a lot. And they were able to simulate that, which is powerful. Now, imagine the resultant impact on the lessening need for example, cooling loads when temperatures are brought down naturally like that so significantly. So the overall impact of that simulation significantly impacted the carbon footprint of that proposed district. And those are the types of things that digital twins at an urban scale are getting really good at.
City Zenith consolidates data and design information into one platform built on a gaming engine. It's a mashup of kind of game engine foundation with data on the back end and data science, which is like the tip of the iceberg. When you open that neat 3D model that you can spin around and see all kinds of data, visualize outcomes, there's a massive back end to that. Digital twinning is about aggregation, visualization, and analysis of scale. Cities that are building out digitally still face some challenges. Questions and concerns remain about security and common language or standards. In the UK, the government in 2018 established a National Digital Twin program to enable the building of a national digital twin. Its Digital Twin Hub is a collaborative, well-enabled community for people and firms developing twins.
The Gemini Principles outlines essentially the overriding tenets to guide the National Digital Twin and the information management framework around that, which is critical because now you're getting into the privacy, right? You're getting into, okay, if everybody has access to this data, then I'm going to be able to find this person in this given location and know for a fact they're there.
The Gemini Principles are 9 basic values that guide the development of the National Digital Twin. They must provide benefit to the general public, enable performance improvement while creating value, and provide insight into the built environment. They must enable security and be as open and transparent as possible using good quality data. A federation of digital twins must be based on a standard connected environment with clear ownership, governance, and regulation, while adapting as technology evolves. The UK's plan to develop common language and standards is similar to the Digital Twin Consortium. DTC's members include many technology companies working in engineering modeling and digitalization.
The Digital Twin Consortium is not a standards body, so we do not set standards, but we certainly help to define some of the requirements around those and then work with the different SDOs out there.
The smart city is on the horizon, and the Digital Twin is the tool that will bring smart cities from the drawing board to life. Engineers have only started to scratch the surface of what is possible, but with the power of simulation, there is no predicting how far the city limits will reach.